Hey everyone, so in this video we're going to look at adding the graphical user interface. So there's already the user interface as far as you can indeed rotate the ball, you can add force, you can click on the ball, but you don't have the indicators to communicate that to the player other than once the ball starts moving. So the way we're going to handle this is we're going to use an arrow, which is pretty common for golf games, at least mini golf games. So the arrow will rotate as the ball rotates, and then we'll also use the arrow to indicate force. We'll have the arrow scale as you add force. There's many other ways that you could do this. You could have the arrow change color. So we're starting off with a white arrow, so you could have it maybe be green for 1/3 force, yellow for 2/3, red for full force, whatever. Whatever you as the designer feels effectively communicates the functionality to the player. So I'm going to use length of the arrow. You could use color. There's obviously certain benefits to length of the arrow because the longer the arrow is, it's actually showing more of the actual path that the ball will take, except for obviously if it's hitting off a wall. We're not doing anything fancy like having the arrow bend. But so having the arrow stretch will actually help aim it a little bit more. So you might not want to take that choice. Instead, like I said, you could use color and you can have the color change based on force, or you could have a separate indicator for force entirely. Lots of way to do this. It's completely subjective. Again, it's whatever you, the designer, feels effectively communicates that functionality to the player. So here is the arrow image I drew. I'm going to mention what I do about all the images I use. There's nothing special about it. It doesn't need to be shared. It's just an arrow. I drew it in Anime Studio Pro. You can use whatever you want except MS Paint because MS Paint doesn't support alpha channels. So I don't think there's any way to differentiate the background easily with MS Paint. You can use just about any other paint program. So it's just an arrow. I did have to make a few adjustments once I dragged and dropped it into the asset area. So if you're going to use this as a sprite, you need to change the texture type. It starts as default. So if you're using it as, say, a material, that would be fine. But we're using it as a sprite, so it needs to be changed to Sprite 2D UI. Second thing, the arrow is too big, so I had to change pixels per unit. If you've never done this, increasing pixels per unit will make the object smaller. Sounds contradictory. Try it yourself, you'll see. So if you want the object to be bigger, you reduce the pixels per unit. If you want it to be smaller, you increase the pixels per unit. There's nothing magical about 320. It's just I started with an image that was too big, and 320 is what made it the size that I thought was appropriate. Completely subjective. Nothing magical about 320. Just know that if you need to change the size, you don't have to start from scratch. You can adjust it with pixels per unit. Lastly, and this does matter, is pivot. The pivot defaults to center. I'll explain in a few seconds why we don't want to. We need the pivot to be at the bottom. So once you make those 3 changes, you hit apply and then you're ready to continue. We take our arrow image, we put it into the scene. We'll take it and we'll drag and drop it onto the golf ball. And the arrow is now a child of the golf ball. Now I want to mention a few things. So first, scale gets changed to 10, 10, 10. I'll talk about that in a minute, why that's relevant. Just for now, know that I believe it's a function of it being added to the golf ball, and then I scaled the golf ball down. Doesn't matter. Bottom line is, in my project, that's what happens. The scale is 10, 10, 10. If it doesn't happen to yours, you can adjust accordingly. So now let's take that arrow. We'll just move it. We'll line it up with the golf ball. Now, once an object is a child to a parent, these are no longer absolute values. These are relative values. Like I said, the scale changed to 10, 10, 10. So the position is also relative. So if you want it to be centered, then it's just 0 and 0 because that's relative to the position of the ball. And the y doesn't have to be that. Actually, the y needs to be a positive because we want it to be like ever so slightly above the green. And then we just rotate this. Okay, so the arrow is a child to the parent, so to the golf ball. So when we rotate the golf ball, which we already have that built in, the arrow will automatically rotate. So you don't need any coding to do the rotation. I wanted to call that out now because when I go through the coding, I want you to know why there's no additional code there. So one of the two functions we mentioned rotation and we mentioned scale. Rotation is handled just by it being a child. Nice, neat, clean. And then the second thing is scaling. So if I had left the pivot in the middle, when we scale this, this would scale out this way. I suppose you could have that, but it would look silly. So in addition to this scaling out this way, this would also scale out that way and would just be really silly looking. So by having the pivot at the bottom, it'll only scale out in one direction. I think that's just about all that we have to do in the hierarchy. I will do this now. So we'll explain how this got here, but for now we're just going to take the arrow and we're going to drop it there, but I'm about to show you why that's there. Okay, so attached to the golf ball is the ball conscript. So the other stuff, other than what I call out, was already here and isn't new. There's only about 8 lines of code tops. Okay, so first of all, public game object arrow. Well, we just looked at that. That allows us to have the golf ball make a direct reference to the arrow, and then it can make direct changes to the object. So yes, we said that the arrow will inherit the rotation, and if we were to do scaling with the golf ball, it would inherit the scaling, but we're not scaling the golf ball. So we need to have a direct reference so we can manually override, manually change the scaling. Okay, because we said that when we increase the force, we want the arrow to scale to indicate that. Speaking of which, our second variable, private float lens scale, so short for length scale, you can call it whatever you want, equals 10. Remember how I called out that the size was 10, 10, 10 when we made it a child? So you need to start with that. You want to start with whatever the scale size is. If yours is 111, then you can start with 111. So whatever the scale of that child object is what you need to use here. Okay, so nothing in the start section, in the update section. So here's space. If you press space, we do a few things. We've added 2 lines of code. So space is what adds force. So lens scale plus equals 0.5f. So we said that the current lens scale is 10. So every time you add force to it, it adds 0.5. So lens scale plus equals 0.5f. Now, if your object is scaled just 1, then you might be using a much smaller number, like lens scale plus equals 0.1. You'll be able to determine that on your own. Just keep in mind that the lens scale is relative to the size of the object, the arrow that is. And then the second thing that happens, so we change the lens scale variable. Now we're actually going to apply that. So arrow, so game object arrow, and now we're just drilling down. The arrow object, all right, what about it? Well, we're going to change a component. Okay, which component? Well, the transform component. Okay, what aspect of the transform component? Local scale. So you're drilling down from general to specific. The object, the component, the element within that component that you want to change. And now we're just changing it. New vector 3, 10, comma lens scale, kind of 10. Again, we're using the scale that we saw in the inspector. So I just want to call that out because if your scale is different, I don't want you to use 10. Use whatever your object scale is by default. Okay, so what I mentioned about the rotation, we're not even going to talk about these other than the fact that we're not going to talk about them. Again, the rotation is already handled just by being a child. Input get key down Q. So this is right now a bit of an override. This is how you basically bring the ball to a halt. You're not going to want this to be a key when you go live with your game. This is really for troubleshooting, debugging. What you would eventually do is rather than pressing a key to make these things happen, you'd probably look at velocity. So once the ball has gotten below a certain threshold, then you're like, okay, that's good enough. We're just going to stop. So we're going to stop the velocity. We're going to stop the angle of velocity. We reset it forward, that kind of thing. So right now, this is just meant to be for the purposes of debugging. In your final version, you would not use a key because your player could cheat. They could hit the Q key whenever they want to stop. So I just wanted to remind you that's what that's there for, because it's actually been a few months in between the first video and this one. Okay, so when we do the reset, it resets the angle of the ball, not new. shuts the angular velocity down, not new. But the reason why I'm mentioning this is I think we need one other line that just does regular velocity. So it would be identical, except rather than angular velocity, it would just say velocity. So probably have to do that to make that work 100%. So the only thing that's new here is this: arrow.getComponent sprite renderer dot enabled equals true. Now you're saying, well, why are we enabling it? Well, because I'm actually reading this out of order, because as far as how this actually gets executed, the ball moving, as you're going to see in a second, we're going to disable the sprite renderer because we don't want to see the arrow when it's moving, when the ball is moving. So we just shut off the sprite renderer. So the arrow is technically there, you just can't see it. And then when the ball comes to a stop, we re-enable it. So if that's why this seems unnecessary, because we haven't actually done the disable yet. Okay, so void on mouse down. So if you've clicked on the ball with the mouse, and here's the bookend to what we're just looking at: arrow.getComponent sprite renderer.enabled equals false. So this is where it gets disabled. This is where it gets re-enabled or enabled. And then this was already here. So total lines of code to make this work, I think I said 8. So 1, 2, 3, 4, 5, 6. So 6 lines of code to make this work. So that's pretty clean and tidy that you could make it work with such a little amount of code. And if I have not forgotten anything, I think this will finally work. And I say finally because this is about my 20th take of this. All right, so let's run it. Okay, so like I said, no coding for rotation. So we rotate the ball, and now we've got the arrow saying where it's going to go. Now we add force, so I hit the space, and sure enough, the arrow does indeed increase in length. Now, like I said, it's not going to do anything fancy like bend. That's just way beyond the scope of this video. And like I said, some people, you might not even want this to scale out like that. You might use an entirely different mechanism. And then you just click on the ball and see the arrow shut off. And then once it comes to stop, we'll hit Q, and there you go. You're ready to go again. So all right, I think that's almost it. I said I would do color. Let's see how easy that would be. So give me a moment. Okay, I'm back. That wasn't too bad. It looks like we're just going to add about 4 more lines of code. So, and you wouldn't necessarily do both of these. You might choose to do just color instead of scale, or you can do both. Again, it's completely subjective. It's whatever you, the designer, feel is correct. So we're adding another variable here. So private color force color equals new color 111. This is when something's white anyways. Well, I shouldn't say white. Whatever color it starts as, okay, so this is white, all right, but if say this was black, its color levels would still be 111 from a unity point of view, okay? So it's basically taking whatever this color is and then subtracting from it or adding to it. So 111 is the maximum amount of red, green, and blue in that image. So we happen to start as white, so it's a perfect correlation because white is 111. But like I said, if you start with another color, then it makes it a little bit harder to pinpoint exactly what you want, because even though these would be 111, you're still already got an emphasis or a deficit of one of those colors. Sorry, not trying to go off on a tangent about color, but that's one of the good things about starting with a white image is you can change it to whatever you want. Okay, so we created the new variable for color. When you click on the space key, we now have to modify the G and the B of that. So force color dot G, so the green level, minus equals 0.1F. Force color dot B, so the blue level, minus equals 0.1.F. Again, the image starts at full color. So even if we didn't do this, it's still starting at 111. Okay, so we are now subtracting green and blue. So if you subtract green and blue, what remains? Red. So that's why we're not doing addition, we're doing subtraction. So that's kind of why I had to go into that tangent to explain that you're already starting at the maximum levels and you're reducing from there. So what this will do is with every press of the space key, it will remove some green, some blue, leaving just red. And so if we run this, there we go. So just as I promised, I did both. You have the lengthening of the arrow and you have the changing of the color. Although red on green, now I think about it, would probably mess up some people's eyes, particularly mine, because I'm kind of red-green colorblind. So like to me, the arrow looks like it's actually standing up straight in the air. It does not look like it's going along the length of the green. So I think that's about it. If you want, I can leave this on the screen for a few more seconds if you didn't pause and cover it already. But that should about do it. So now you have the ability to show the angle the ball is going to shoot at. You have the ability to two different ways show the amount of force. And we'll see if anyone wants to see any more of this series. If so, just leave a comment and a like. Let me know what you'd like to see next because it's a mini golf game. The bulk of what makes the challenge is the course itself, just coming up with crazy ramps, and all that is going to be done in your 3D modeler. I used Asset Forge because it already has a built-in set of golf course tiles. So I literally made this in like 20 minutes. So you can use whatever you want, but I used Asset Forge. And I already showed you how to do the sand trap. But maybe one or two other things I could show you. Like I could show you how to do like a portal. Like I've seen that. Certain things like windmills that you see in actual mini golf, that's pretty easy. That's just angular rotation applied to the windmill itself. But if you really want to see things like that, let me know. Um, Otherwise, so I hope that you found this useful, and please do enjoy the rest of your day.